this point, I'd like to introduce Wim Henderickx, who will be presenting Revolutionizing Network Automation with Kubenet Beyond Containers. Wim is the head of technology and architecture at Nokia and traveled from Belgium to join us today. This is Wim's first time presenting at NANOG, and it's a pleasure to have Wim speaking with us today. Let's welcome Wim.
Thanks, Steve. Is it on? It's always good to see that many people still interested in network automation, right? So, and I want to show a hand. So, who is actually busy with the network automation? Because this talk is basically related to that. So, there's quite a few hands, right? And the second thing is basically the thing that I'm going to talk about, or what I'm trying to do in this session. So, this is basically more like an educational thing, I have to say, is basically to demystify what basically this Kubernetes thingy, right? And I don't know how many people are familiar with Kubernetes as a system. And can I see a show of hands of how many people? So that's pretty good. How many people have used it? Okay, so that's pretty good. So yeah, so basically what I'm trying to do, because I was expecting less hands, which is actually interesting, to basically demystify a little bit this, I think what I call the wheel, right? So this is basically the signature of Kubernetes, and it's basically the salesman who's trying to drive the ship. But what Kubernetes tried to do at its base is trying to orchestrate containers, right? So that's what this core mission was about. And what I felt so I had at some point a task from my boss to say, okay, what do we do next in automation, right? And I basically started to dig in and said, okay, do we reinvent the wheel, or do we try to figure out what is going on the other side, right? So, and I was digging into the system, and I said, okay, if I look to Kubernetes and if I have to summarize the situation, I would basically say there is two things that it does. There is one, it does container orchestration, but the guys also built what I call an API machinery to do automation. And it's actually built, if you dig deep, in such a way that the use case doesn't really matter, right? And what I try to do in this talk is try to demystify that to see how we could leverage potentially some of those mechanisms in the networking space, right? Now to start, so in other words, I'm trying to not talk about containers. I'm going to do some analogy, but I'm trying to not talk about containers at all. And I try to basically give you a bit of the building blocks that is being used in order for you to understand how we could apply it to networking, right? So at its base, what is there? It's an API server. So think of it as a web server that we have, as we all interact with, right? And at its core, it has, so they talk about APIs, and the terminology that they use is resources, right? So it's a resource. So an API, like think of people familiar with Yang, it's a schema, you do validation, and you basically can define it. So the nice thing that they also did is, they of course, when they started, they built specific ones for containers, but in the meantime, the system is extensible, so you can plug in your own APIs. So one of the things that we will talk about is, okay, let's plug in some network APIs and network resources that we can use to actually automate and orchestrate our networks, right? The second thing they have there is a database, right? And so at its core today, it's used etcd, which is basically a key value store, right? But the interesting part is you can also change that, right? And so some people are looking at version control and they try to do change management and stuff like that. So you can actually change it to a version control database. So now you can actually have APIs with a version control backend and you can do change control, right? And then the third thing that they have is basically they leverage this, what I call, or reconcilers or controllers, or what sometimes in the, people familiar with the terminology in Kubernetes also called operators. So they have this system that basically watches events that are happening on the API server and they react, right? So that means that, okay, so in their world, so they schedule a container, right? And if it doesn't perform there, they will schedule it on another node and stuff like that. So the nice thing is it reacts dynamically to events. And that's also a very nice property because it's not like a one-shot thing. It's basically something that you can monitor. My interface is down and you can take an action, right? So it basically gives you a lot of properties to build upon, in my view, and that we can leverage in various industries, right? And what I've seen and why I want to basically do this presentation is basically you see other industries adopting that API machinery for other environments, right? And the question is why not networking, right? Now, going a step further, if you look to that API, basically the way it is defined is there is a schema, right, as I said before, and here is an example of one of that. So of course this is a container one, so a pod is basically, think of it as a resource, right? So looking at the previous picture, the pod is a resource, and the nice thing is you can basically customize the system with whatever you want. The thing that they did, in my view, as a consumer is interesting, is declarative, right? So that means if you say, I want 5 pods, you just change the number 5, and the system will figure out to make that happen, right? So as a consumer, from an automation, that is a property that is really interesting, right? Because it means that the interactivity with the system is really simple, right? As I mentioned, in the meantime, it's basically extensible, and so the terminology that they use is custom resource definition, right? So you can forget about the name, but the thing that you have to remember is it's extensible, so you can customize the APIs or the resources depending on your use case, right? But also it's event-driven, so it's different than if you compare it to like an Ansible or a Terraform, which is what I classify as workflow systems. So there is an order at which things execute, right? In Kubernetes, it's basically you get an event and you do something with. And at the end of the day, what you see under the hood is that the system can be consumed in a much more dynamic way and actually can be used also in a live environment to do that reactive communication when things are happening, right? Long story short, this is kind of how the API looks like and one of the semantics that you have. But for example, some of these things like the desired state, which is basically you're declaring, I want to achieve that, right, is what is basically represented within the spec, right? Now, as I mentioned, so they have this control loop, right? So basically, think of it as there is a sensor. So you build a piece of you build an application, and you want to react. Let's say you want to react to an interface down event, and you want to do something with it. So they basically have this control loop. And the other thing that I like, or that I want to share, is they built the system in such a way that they divided and conquer all of these resources, and they inherited this philosophy of Unix to do one thing and one thing well, right? Because each of these controllers is designed to do one thing, and of course, in the Kubernetes world, it is container orchestration. In the networking world, it would be networking specific tasks that you would execute, right? Now, I try to summarize it here, right? So there is, of course, a bunch of technical reasons, which I think I went into already a little bit. There is also a lot of non-technical reasons, right? Which is, it's actually open source. It is vendor agnostic, right? And it's very extensible. But also, what you see is that there is a huge community out there that we can leverage because we're all screaming for more software developers. If you go to KubeCon, for example, it's a conference with 10 to 15,000 people. Just to give you a sense of the amount of, let's say, people actually doing it. And they also meet 3 times a year, by the way. So it's huge. And so why I think it's important is that typically here in this community, we are less involved in that. But I think it's also interesting for us to see what's happening on the other side. Now, if you compare that machinery with containers, right? And so how different is networking, and is networking so special that we could not leverage that, right? And that's for me, when I started, was my fundamental question, right? And I basically built, or I tried to understand what did they do, right? And I try to summarize it here. So basically what they did is they say, I have a problem space which is container orchestration, right? And for us it would mean network automation and orchestration, right? And they divided that problems, so they segmented the problem space into various components, and they said, for my domain, this is what I wanted to do, right? And they built these reusable components that are built with this Linux or Unix philosophy to actually do that particular domain and try to orchestrate for, in their case, orchestrations, right? But they also built this abstraction layer, they built this declarative system, reactive and stuff like that. But the machinery under the hood is built, which is very generic, right? And I then built this, and this is a very simplistic picture. But if you look under the hood, they have a resource called a deployment, and then they have pods, which is basically a representation of containers. Actually, there's multiple containers in a pod, and they schedule it on a node, right? If you would do the simplistic view of networking, what do we have? We have a network, or a virtual network, or whatever you call it. We have a bunch of interfaces, and we have a set of devices, right? So at its core, what you actually have to do is basically look at your domain and segment the space into the components that actually accomplish the task that you want to do from an operational community for that particular domain, right? And if I then have to, I would summarize it, I say what is different between networking and containers? First of all, the use case is different and the domain is different. The protocols are different, right? The APIs are different and the skills, right? But that doesn't mean that the machinery on which you build your automation has to be different, right? And that's the journey I went through, right? So the first thing is, of course, how can we apply that declarative API that you saw before for a container onto network devices? So can we actually interact from a Kubernetes API with a router or a switch, right? And ideally, do it in a vendor-agnostic way, right? That is able to give us that declarative interface to interact with that device, right? And the first attempt that I had is actually we built a system that actually, so I proved that we can do so, okay? And that's why we started an initiative from Nokia, but in the meantime, there is other people involved, to actually, and that's one of the reasons why I'm doing this talk, is basically to learn and share the experience with the community around that system, right? And so we built in Kubenet, not only, so we try to educate and we try to explain how the system works, but secondly, we also built a set of open source components to actually show and prove that we can actually do that, right? And the first component that we built is actually a component that allows us to interact with a device, because as long as I cannot interact with a device, people will say, okay, it's unusable for me, right? And to do that based on the principles itself. So what did we do? As a starting point, we said, okay, we started so there has been a lot of initiative around Yang and stuff like that. So we took Yang as the foundation on which we built, right? And we said, okay, can we map a Yang-based system, irrespective of which vendor it is, whether it's Arista, Cisco, Juniper, Nokia, it doesn't really matter. Can we actually interact with that device in a declarative way, right? And so the thing what you have to bear in mind, what is the difference in a declarative system, is I would say it's read heavy, right? Because what you do is you give let's say you say, I have VLAN 1, right? And then you say the same configuration, let's say VLAN 1 changed to VLAN 2. So the system under the hood needs to say, is VLAN 1 configured, and how do I get it to do VLAN 2, right? So what you actually have to do in a declarative system is basically read what was there, understand what you need to get to, and basically do the diff, right? And then execute the diff. That's in essence what you have to do. But in order to do that, it is rather read heavy in order to figure out what is going on and trying to do that, right? So the first attempts that we built is that we actually killed a bunch of boxes, right? Because we went straight onto them, and so they were not designed to actually have this heavy read type of operations. So we actually built a capability, and so there is an open source tool called schema-driven configuration, which basically allows us to interact or to expose let's say a Yang-based system in the Kubernetes. So, and you see some of the components or an example of this here. So this is a very simplistic view. So it's just an interface, and you basically say it's on this device, and the system will figure out it has this schema, it is this vendor, right? And it's this model, and we will do the validation for it, right? And it basically acts upon that in a declarative way. And that's basically the first component that we built. Now, as I said, and I don't have the time to go in all of these details, right? Because there is a lot of stuff going under the hood. But so we build it in such a way that we actually can do that in a vendor agnostic way. And it's not, so we are still testing, so it's not yet 100% there yet, I have to say at this stage. But we have been testing with Arista, Cisco, Juniper, so most of the vendors. And even we've tested with things that are not related to networking at all. So there's people who are consuming it, for example, in 5G, 4G, like, because any device that has a young schema, we could actually support with that, right? So that's basically what this system does. We built a caching layer in between to avoid and to deal with vendors that are not supporting a very let's say, optimized system, right? So in order to actually be able to cope with that. And of course, per vendor, there is still, it's not like you load the schema and it's all there. There is a few knobs that you have to do in order to make it work in an interoperable way. But at the end of the day, it turns out not to be such a hard thing to build, right? So once we said, okay, now we can interact in a declarative way from, let's say, that declarative API towards a network device, let's look at the next layer, right? And so, yeah, before I go there, it's not just configuration. So for example, the API that we expose is you can, for example, get the full running config of a device and basically use it for backup reasons, for example, right? But we also build it in such a way, what you typically see in an intent-driven system is that you can only, so from the moment you are in management mode, you cannot no longer touch the box, right? And I believe in automation that the trust in that automation system from the beginning is not there, so you have to allow people to actually change and do configuration things on the box as long as that system is not yet 100% trustable, right? So we allow for you to do changes, but we will report on all the deviations that are actually happening when, so that are compliant or not into the network. Plus, you don't even have to manage the whole system. You can start with small pieces to actually say, okay, I'm only interested in this particular piece of management, and I try gradually to move to that mode of operations, right? So it's not like a big bang, right? And we still allow you to go, for the CLI lovers, to go straight onto the box without actually changing the system. So we try to make it flexible to give you the choice and to actually gain the trust into the system in order to leverage that, right? Now, from the moment that we said, okay, we can interact with the system from that API, how can we now manage and orchestrate a network as a whole, right? Because it's not just, so most people, networking is typically a number of platforms, so what can we do? And at the end of the day, we copied what Kubernetes basically does, is we said, okay, for our domain, which is networking, in order to be able to do the orchestration and the automation, what do we need? We need a topology, right? You need a way to get IP addresses and VLANs and AS numbers and so on and so forth, right? And we also would love to do some abstractions, right? So, and at the end of the day, I was of the opinion that you want to have an abstract type of API that basically trickles down to eventually device configuration, which are abstracted and can be rendered to the device-specific implementation that you have through your Jinja templates that a lot of people have developed, right? And so that's basically what we did in Kubenet from the beginnings. We basically said, okay, how can we segment our domain and build these reusable building blocks in order to actually prove that we can leverage the automation platform, that we can leverage Kubernetes as a system to do the automation orchestration for our network, right? And how that looks like, and this is not the full set, so this is a bunch of APIs or resources that you saw from the beginning that we actually developed to actually do our automation and orchestration use case. And we started with EVPN, with VXLAN, right? But the system is built to be flexible and to be accommodating different domains. The nice thing that I personally like, and of course you have to give me that feedback, is that all of these APIs are changeable, right? So the system, so you can customize the system completely and tailor it for your use case, right? But of course, we benefit from the fact that we collaborate on some of these things. So we said, okay, let's try to show and prove that it's possible, and then we take it from there. To give you some examples, I have them here into the slides for illustration, right? So here are some of the examples, how they look like. We also try to segment the, or do some work in the abstraction layer. For example, when you deliver a new service, and people have used VXLAN, and other people have used MPLS, and other people have used RSVP, or people have used SRv6 and stuff like that. We wanted to give you or abstract that thing from the API, so that's why we have designed like this network design concept where you say, I want to use IPv4 only, dual stack, v6 only, and stuff like that, so the things, the system will help figure out how that works, right? Now, we also try to build it in such a way that you, as a network automation engineer, can customize it yourself, right? Because in automation, I'm of the firm believer, it's not like here is the thing and it works. It's basically you need to be flexible to customize it for your environment because we all have our little differences that we all love, and we want to adhere to that, right? Now, so as a network automation engineer, what are the things that you have at your disposal? So of course, in Kubenet, we gave you a bunch of reference APIs, if you will, right? So you can, of course, leverage that, or you can basically build your own. But for me, what I found personally, the hardest part is basically the modeling as a whole, right? So for me, the thing is, it's good to extend, right? To model it as because you actually do a network design, like we do network designs to say, okay, this is a scalable thing. If you look at this, it's network design at the software layer, but it's similar type of semantics, right? So for me, that was, so my message or my experience is basically designing and decomposing the system in such a way that you get a good, reusable and maintainable software was, in my experience, the more tough job compared to building it at the end of the day. Now let's look at use cases, right? So there is people, how would you use it? Or in what environment would you use it? So the first, so this is actually coming from a live presentation. So from people that have presented that, if you look to the QR code, you can watch their talk. Their goal is basically to use Kubernetes as a system, and they leverage GitOps tools, like they leverage Argo CD. So if you are in the Kubernetes ecosystem, there is a huge GitOps ecosystem that's being developed. So they basically said, okay, I have a way to get my golden config in Git, and I want to use the system to basically transact and make sure that my real running configuration is aligned with the desired configuration, and they leverage that system for that. A second use case that you have is basically, what I said is this config generation, right? And do that, so basically, what we typically want to do as a network, in the networking, we basically do have device configurations that are being used into our networks, and typically when we have change, we add a VLAN, we add a BGP peer, we add an AS number and stuff like that, that's changed, right? And so what you want to do, or ideally want to do, is basically have a system that helps you customize your environment to generate those configurations, right? And ideally, you want to do that in change control so that you actually know what is the diff between what you were running today and what the new thing is that you want to get to. And you ideally also, in my view, want to have a system that allows you then to take that, validate, to see whether you are okay with all the changes, and only when you're happy, you actually transact to the device, right? So these type of environments, so that's where there is quite a bit of interest. We are just to be fair, so the current version of Kubenet that we did was basically to prove the point, meaning we built the APIs, we did the decomposition. We didn't build it yet for customization. So in the next couple of weeks, we are releasing that whole capability to allow you to customize the system in a very easy way. Because although I'm promoting Kubernetes as a system, there is also some, let's say, things that I would say are negative or not so good, right? Because it's all, I can say here, it's all green, right? There are negatives. One of the things that I found as a negative is, as a person, as an outsider, to actually customize, right? The CRD and the extension of the API is easy. The software to act, you need to, most of these controllers are written in Go. There is also Python, but the amount of software is still, you have to go quite deep to actually build that properly, right? So we tried, with the things that we are releasing, is we are making that as simple as possible. So a controller can be a Jinja template, you see? And you get the same declarative operation from there, right? So we try to, because the feedback that we had so far was, okay, it's all nice, right? But I, as a automation engineer, I'm not typically the biggest software developer on the planet, right? So we wanted to make that barrier of entry very low, so that basically the thing that you have to build can be as simple as a Jinja template, right? And that gives you the desire of what you want to achieve, and the system for you will take care of that. So I have to be honest, at the moment, so wait a couple of weeks, then this type of use case will be way more easier to consume, okay? The other thing, and I think I mentioned that, is the change management. So all the things, so we leverage Git as a database, as the backend, to be able to actually leverage that whole change control, peer reviews, and stuff like that, to leverage that system. And then, of course, there is a lot of operational tasks that also, where people use that controller system for, like backup and restore use cases, audits. So for example, some people use it to install certificates or to rotate certificates on the device, right? So it's even used in that mode. And there is even a link to Let's Encrypt. So if you look, so there is a whole certificate management system, basically to actually renew certificates and stuff like that. So there's many use cases that actually can be leveraged with the system. And so that's my message to end with, is that I believe there is a lot of power that we can leverage from that ecosystem. And I believe it's worth having a look at or experimenting with. So that's what we are trying to do with Kubenet, to actually help you get into that ecosystem and try to help leverage yourself to get acquainted with that environment, okay? And so if I hopefully give you a lot of appetite to look at it, you can join us, and we are here happy to learn. We're also doing a bit of work in AutoCon, so I see Scott there. So we'll have a workshop where we actually do a deep dive with hands-on labs where people can experience. So we are trying to help you guys all ease that entry into that ecosystem, right? And so with that, I even was on time. I think if there are questions, I think we have a few minutes.